Hey everybody, this section talks about polynomials, linear factors, and zeros, and how all of those things are related. We are going to learn how to analyze the factored form of a polynomial, and we're also going to learn how to write a polynomial function from its zeros. So in this screen, it says if p of x is a polynomial function, the solutions of the related polynomial equation, p of x equals 0, are the zeros of the function. Okay, so the key idea is to be able to find the zeros of that polynomial function, and that'll help you factor that polynomial and graph the equation, graph the function, and solve related polynomial equations. So in chapter 4, we solved quadratic equations by factoring. We wrote their linear factors, and we applied that zero product property. So we can solve some polynomial equations that same way. So let's take a look at this first example. If I'm asking you what is the factored form of this x to the third minus x squared minus 12x, one of the first things that you want to look for is to factor out the greatest common factor. So anytime that you factor, that's the first thing that you want to look for. So if I factor out an x out of that polynomial, I have x times x squared minus x minus 12. And then the question is going to be, can we go ahead and factor this portion right here any further? That's the question. And what you're looking for are two factors that multiply to get negative 12 and add to get negative 1. So these linear factors, this quadratic goes down to linear factors of x minus 4 and x plus 3. So factored form is this x times the quantity x minus 4 times the quantity x plus 3. Notice there are 3 linear factors, which matches up with that degree of 3. Looking at this second example, we have x to the third minus 25x. Again, looking for that greatest common factor, I'm going to factor out an x, and I get x squared minus 25. Looking to see, can you factor this any further, this x squared minus 25 any further? The answer is yes. It is the difference of squares, and it will factor into two linear factors, which are x minus 5 and x plus 5. That is my factored form of my polynomial. It has 3 linear factors, which matches up with the degree of 3. Okay, so just a quick reminder as to how to factor. So this brings us to our roots, our zeros, our x-intercept. And I want to make sure that you understand what all of those things are. So I've got 4 statements. They're all going to be equivalent statements about a real number b and this polynomial p of x. So notice this p of x equals a sub n x sub n plus a sub n minus 1 x sub n minus 1 plus yada 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 plus a sub 1 x plus a naught. That is just a generic polynomial function. Here's what I know based on that. If I have this real number b, then x minus b is a linear factor of the polynomial p of x, right? X minus b is a linear factor. Now b is a 0 of that y equals p of x. It's a factor of that, or it's a 0 of the polynomial function. Now b could also be called a root, I'll say, or solution to the polynomial equation when the polynomial equals 0. I could also say that b is an x-intercept of the graph of my polynomial function. So when we have linear factors, the zeros, the roots, the solutions, the x-intercept are all equivalent statements. Okay? So let's head to our first example. What are the zeros of this polynomial function? And we need to graph it. So we're going to take a look at y equals x times the quantity, x minus 3, times the quantity, x plus 5. I'm going to grab a new color here. And there's some things that we know about this polynomial function, and there's some things that we need. Okay, things that we need to know, I guess I should say. We need to know the zeros. So I'm going to just kind of make a list here. We need to know the zeros. We need to know any additional points. And we need to know the end behavior of our graph. So the plan is to use the zero product property to find the zeros, find points in between the zeros, and sketch the graph. Okay, so the first thing that we're going to do, I'm going to go ahead and kind of bubble this in. Those are some things that we need. Let's find the zeros. So I'm going to use the zero product property to find the zeros. So that means, let's see, if I have x times x minus 3 times x plus 5, I want to know when does it equal 0. Well, it equals 0 when x is 0, or x minus 3 is 0, or x plus 5 is 0. Well, that means x is 0, or x is 3, or x is negative 5. Okay? So the zeros of the function are negative 5, 0, and 3. I'm going to go ahead and just kind of start my graph over here. And I'm going to put the zeros on this graph. So negative 5 is a 0. 0 is a 0. And 3 is a 0. Okay. All right, let me pick a different color. We'll just go some purple here. So I need to find some points for x values that are between those zeros. So for example, I would kind of like to plug in, let's just say, I'll just call these additional points. I'd like to plug in, say, something that's part way between negative 5 and 0. So let's just substitute in, say, negative 3. And I'm substituting in negative 3 into the equation. All right, so I have negative 3 minus 3, negative 3 plus 5. So this is equal to negative 3 times negative 6 times 2. Well, let's see. Negative 3 times negative 6 is 18. 18 times 2 is 36. That means the point, negative 3, 36. So I'm going to go here by tens, and I'm going to graph these additional points. So I'm going to go to negative 3 and 36 and make an additional point. Okay. I'm also going to pick something that is between 0 and 3. So let's just say, I don't know, 2. So if I plug in 2, that means I'd have 2, 2 minus 3, 2 plus 5. So that is 2 times negative 1 times 7. Well, let's see. That is negative 14. Still, I'm going to go by tens here. So that would be a negative 10. So I have 2, negative 14. Okay. All right. So I also have to take a look at the end behavior. And the end behavior, since this would be, if I multiplied this out, let me go ahead and do that. Let me get this polynomial in standard form, highest degree to lowest degree. And I'm going to go ahead and FOIL, and I get x squared plus 2x minus 15. When I FOIL that out, distribute the x, that's x to the third, plus 2x squared minus 15x. Notice it has a degree of 3, and the leading coefficient is positive. So that would tell me that the end behavior is down and up. So that means over here to the left, the graph's going to go down, and over here to the right, the graph's going to go up. Okay? That's the end behavior. I can go ahead and graph what we have. We've got this going up, going down, and going back up, following that end behavior. So that is a graph of the function y equals x times the quantity x minus 3 times the quantity x plus 5. Okay. And that's using the zeros, some additional points that are in between, and the end behavior of that polynomial. Let's talk a little bit about the factor theorem. And the factor theorem describes the relationship between the linear factors of a polynomial and the zeros of that polynomial. So the factor theorem says if you have an expression x minus a, and it's a factor of your polynomial, if and only if the value of a is a zero of that related polynomial function. All right, so here's what that means. That means that a is a zero, then x minus a is a factor. Or if you know x minus a is a factor, then a is a zero. For example, if 3 is a zero, then x minus 3 is a factor. Now, what happens if I have, say, I don't know, negative 4? If negative 4 is a zero, then the factor would be x plus 4. That would be your factor. Okay, so understanding that the factor theorem, it kind of goes in both directions. If you know the zeros, then you can find the linear factors. And if you know the linear factors, well, then you can find the zeros. Let's take a look at this example. It says, what is a quadratic polynomial function with zeros of 3 and negative 3? Well, here's what I know. If I have a zero of 3, then that tells me the factor is x minus 3. If I have a zero of negative 3, that tells me the factor is x plus 3. So if I'm trying to write my linear, my quadratic polynomial function, see, a quadratic has a degree of 2, that means it would have 2 factors, then I can say the function would equal this x minus 3 times x plus 3. It's a product of its linear factors. Well, if I multiply and simplify, I'm going to get x squared plus 3x minus 9. Well, the function is x squared minus 9. Okay, so that would be the polynomial, the quadratic polynomial that has zeros of 3 and negative 3. It would be f of x equals x squared minus 9. Okay, so now let's take a look at, here's a cubic that has 3 zeros. So this cubic function has 3 zeros. So that means if I have a zero of 3, I'm going to have a factor of x minus 3. And if I have another zero of 3, then I'm going to have a factor of x minus 3. And if I have a 0 of negative 3, then that factor is x plus 3. Okay? Now, if I write the cubic polynomial function as a product of its linear factors, well, then that function equals x minus 3 times x minus 3 times x plus 3. Well, we've already established multiplying those two parts, I get x squared minus 9. So now, when I FOIL, I'm going to multiply the first term, and I want to FOIL it to get it into standard form. So my first term is x to the third. The outside term is a negative 9x, and the inside term is a negative 3x squared. And the last term is a positive 27. Now, writing that from highest degree to lowest degree, x to the third minus 3x squared minus 9x plus 27 is the cubic polynomial that has zeros of 3, 3, and negative 3. All right? Now, this 3, 3, and negative 3 zeros is going to come into account with what we talk about next. So we found that our linear factors for that cubic polynomial function that has the zeros of 3, 3, negative 3 was written as f of x equals that x minus 3 times x minus 3 times x plus 3. That means we have repeated linear factors of that x minus 3. Well, that makes the 3 a multiple 0 because the factor happened twice. Well, that would mean that the 0, 3, has a multiplicity of 2 because it happened 2 times. So since you know the zeros and you know the linear factors, you can talk about its multiplicity. So in general, a is the 0 of multiplicity n means that x minus a appears n times as a factor. So for example, x minus 3 appears twice as a factor, and that means the 0, 3 has a multiplicity of 2. All right, let's take a look at that a little closer. So let's take a look at this example. We have f of x equals the quantity x minus 1 quantity squared times the quantity x plus 4 times the quantity x plus 1 to the third power. All right, so here's what I see. And I want to talk about like what happens to the graph around those multiple zeros and how's the graph affected by multiple zeros. So when you look at the zeros and the multiplicity, it'll tell you a little bit about the behavior of the graph at that x-intercept. So when I look at, say, this x minus 1 quantity squared, the 0 would be x equals 1. So what that means at x equals 1, there is a degree of 2. Well, if it's a degree of 2, that is a parabola. So at x equals 1, it's going to look quadratic. I'll put parabola in parentheses there. It's going to look like a parabola at that 0, x equals 1. Take a look at this x plus 4. Well, that 0 is going to be x equals negative 4. Well, it has a degree of 1. Well, that means it's going to look linear. In other words, it's going to look like a line at the 0, at the x-intercept, x equals negative 4. And then last here, I have x plus 1 quantity cubed. Well, its 0 is negative 1. And with that, it has a degree of 3. So that means at x equals negative 1, it's going to look cubic. Okay? So let me pull my calculator out over here, and let's kind of keep this in mind. So at x equals 1, I'll write it here to the left, it's going to be a parabola. and at x equals -4, a line, and x equals -1 cubic. All right, so I'm going to go to y equals here. And I need to go here to the left. And let me just get to the line there. Okay, so let's enter the function. So I've got parentheses, x minus 1. Oh, looks like I hit x too many times. Now let's clear that out. Let's go parenthesis, x minus 1, and I'm going to arrow to the right, squared. I don't know why it's hitting twice, but now it's hitting 3 times. I'll try again. Let's go x minus 1, squared, and then parenthesis, x plus 4, and parenthesis, x plus 1, arrow out, and I needed to go to the 3rd power. Better hit enter. There we go. Okay, so we need to graph this. Notice that my graph here at this 0, at -4, notice it looks like a line. At -4, it looks like a line. Here, at -1, it looks cubic. And then at 1, it looks like a parabola. Okay, so just by looking at the multiplicities of the zeros, you can get an idea of what that graph is going to look like. All right. So, if a is a 0 of even multiplicity, then the graph of the function touches the x-axis at a, and then it's going to turn around. So if you have an even multiplicity, if the degree is even, it's going to touch the x-axis. If a is a 0 of odd multiplicity, then the graph of its function is going to cross the x-axis. So if you have an odd degree, the graph will cross the x-axis at that 0. All right? So let's take a look at this example. It says, what are the zeros, what are their multiplicities, and how does the graph behave at those zeros? All right, so I'm going to take this function, f of x equals x to the 3rd minus 4x squared plus 4x, and I need to factor that polynomial. So I'm going to take out an x, and because that is the greatest common factor, and I've got x squared minus 4x plus 4. And then I'm going to say, well, can I factor that any further? Let's see, 2 numbers that multiply to get a positive 4 and add to get -4. So that'd be a -2 and -2 are the linear factors. Well, notice that can be written as x times the quantity x minus 2 quantity squared. Okay. So what are the zeros? Well, the zeros will be x equals 0 and x equals 2. Those are my 2 zeros. The multiplicity. For multiplicity, you can look at the exponents. So x equals 0 here has a multiplicity of 1. It only happens one time. What that tells me, it's going to look linear at x equals 0, and it's going to cross the x-axis because it has an odd multiplicity. Now at x equals 2, its degree here is 2. So notice this degree was 1, this degree is 2. So it has a multiplicity of 2. Now what that means is that it's going to touch the x-axis. What I know by that, it's going to look quadratic. I can use that information and present a graph. So let me get a color and let's do a graph. So with that, I have my zeros at 0 and at 2. In order to graph it, I have to look at the end behavior. The end behavior is down and up. What I know is that it looks linear, looks like a line at x equals 0, and it looks like a quadratic at 2. So my graph's going to look a little something like that. Notice it's not perfect, but it gives us an idea of what the graph's going to look like. All right, so if you have a graph of a polynomial function that has several turning points like the one we just had, the function can have a relative maximum and a relative minimum. So here is a relative max. That is where the function goes from going up to coming down. It'll have a relative min when the graph goes down and then it turns up. Okay. So on this last screen, we have a relative maximum and a relative minimum. Okay. Again, maximum is where it goes up then down. Minimum is where it goes down then up. It is a turning point, is what we call them. So what are the relative maximums and minimums? Okay, well, let me write this equation over here to the left. And I'm going to attempt to use that calculator again. And I will do a separate video on how to do it on the TI-84. But I just kind of want to show you what that looks like. Let me go to y equals. I'm going to go up here and clear that out. And I'm going to enter 3x to the third power plus x squared minus 5x. Okay. And if I graph that, you'll notice here that you have an increasing graph. It has a relative maximum. It decreases. It has a relative minimum. And then it's increasing. So I want to calculate those zeros. Nope, I want to calculate number 3. Let's go minimum. Okay. So you'll notice that you want to get, for the minimum, let me get to the minimum, a left bound, and you'll push enter. You just need to get to the left of that minimum. A right bound, get to the right of the minimum, and then notice it tells you what that minimum is. Okay, a lot of times you've got to go back for a guess and then push enter. So here's what I know, that I have a relative minimum at the coordinate 0.642 and negative 2.004. Now, I also see that I have a relative maximum. So we're going to calculate the max. Go to second trace, which is calculate. You're going to go down to number 4, or just push 4. And notice it says left bound. I need to get to the left of that maximum, enter, then get to the right of the maximum, enter. Now yours is going to ask you to guess. Just arrow back one more step and push enter. And you're going to get the maximum point at negative 0.86, well, negative 0.0865 and 3.132. And there you go. That's how you're going to find your relative maximum and your relative minimum. Okay. All right, so let's take a look at this problem. And this will be our last screen, and it's going to take us through everything. We've got to be able to find the zeros. We got to talk about the multiplicity and how it affects the graph of your polynomial. Give a little sketch of the graph, and then we'll use our calculator to calculate the relative minimums and relative maximums. Okay, so let's start with this equation. Y equals, notice this x to the fourth plus 3x to the third minus 4x squared. I can factor out an x squared. And that gives me x squared plus 3x minus 4. Well, factoring the x squared plus 3x minus 4 further into linear factors, that would be an x plus 4 and an x minus 1. Here's what I know. The zeros, x equals 0, has a multiplicity of 2. X equals negative 4 has a multiplicity of 1. It only happens one time. And then x equals 1 has a multiplicity of 1. So here's what I know. If it has an even multiplicity, it's going to touch the x-axis. If it has a multiplicity of 1, odd multiplicity, it's going to cross the x-axis. So if I do a little sketch here, let me pick a different color. If I do a little sketch here, and I have a 0 at 0, negative 4, and 1. Well, it is an even degree. That means it is up and behavior. Now, at x equals 0, it's going to touch the x-axis. At x equals negative 1, cross, and x equals 1 is going to cross. So negative 4, it's going to cross and look linear. Well, then that means it's got to come down, turn. It's going to act like a parabola, and then it's going to act linear. That's a possible graph. Just the shape of the graph. It doesn't give me the exact graph. It just gives me the shape of the graph. So I'm going to grab this calculator again, and I'm going to enter this polynomial function. So x to the fourth plus 3x to the third minus 4x squared. Okay, I'm going to graph it. Notice it gives me a little bit. I'm going to change this window just a smidge here and have my y minimum go down a little bit more. We'll go negative 20. It's a little bit better. Okay, so it gives you an idea of the shape of that graph, and I have to find the zeros, and I have to find the maximum and minimums. Probably would help if I change that window so we can find the minimum here. Okay, so notice it's not exactly like my hand drawn one, but it's pretty darn close. All right, so here's what I know. I can calculate the minimum, I have 2 relative minimums, and I have 1 relative maximum. So let's calculate the minimum. And I'm going to get to the left of the minimum, push enter, to the right of the minimum, push enter. You want to shimmy back and push enter again for your guess. So I have a minimum here at negative 2.93 and negative 36.1. Okay? Then the graph's going to increase and then decrease. That is a relative maximum. So I'm going to calculate and go down to the maximum, and I need to get to the left of the max, and then get to the right of the max, and go back to where you think it is. And notice this one is pretty darn close to 0, 0. We'll just call that 0, 0. And then I'm going to have one more minimum. So I need to calculate that minimum. I need to get to the left of the minimum, to the right of the minimum, shimmy back, push enter again, and you're going to get your minimum at 0.68 and negative 0.69. Okay. Notice this one has 3 turning points. Okay. All right, I think that about does it for our video.